A rocket is launched in the air. Its height in meters above the sea level as a function of time in seconds is given by this function right here. H of t equals negative 5t squared plus 220t plus 235. Find the maximum height of the rocket attains. So here, what we have to recognize is that this is a quadratic function. Okay? The quadratic means the highest degree is 2. And so let me write this here. Since we have negative 5t squared plus 220t plus 235, we see that right here is negative coefficient. When's the highest term, the degree with the term with the highest degree, when it's negative, we know that the end behavior of this function is something like this, go down. But because this is a quadratic, it will actually just parabola like this. So therefore, finding the vertex will allow us to find the maximum height. So this problem is essentially vertex problem, finding a vertex. So vertex, we know that is negative b over 2a, comma, f of negative b over 2a. Well, in this case, it will be h because function is h, but the same idea. So let's find this one first. This is b. This entire thing is a. So the x value for the vertex is negative b, so negative 220 over 2 times negative 5, which is negative 220 over negative 10, gives us 22. So that's the x. So if you look in the graph, this value right here is 22. Now, in order to find the maximum value, we have to plug 22 to the function value. So you have to plug 22 right here. So let's do that. So if I plug f, well in this case h of 22, I get negative 5 times 22 squared plus 220 times 22 plus 235. So once we calculate this, we'll get the maximum height in meters. So let's do this calculation. So let's do one at a time here. Maybe a separate room here. I know that 22 square is, what is that? 44, 44, 484. So we have negative 5 times 484 plus, this would be also 484, but we have one more zero, so it'll be 484 with one more zero plus 235. So let's do 5 times 484 was negative, multiply negative 5, right? Which is 20, 400, and what is that? 2000. So we have negative 2420. So what we have is negative 2420 plus 4840 plus 235. Okay, this is kind of the side. And if I add all these, I get, let's see, 260, 2655 meters. So this is the maximum height. So the vertex is technically, let me write it. The vertex is 22,2655. This is the vertex. So when time is 22 seconds, the maximum height is 2655 meters. For the quadratic function, 3x squared plus 5x minus 2, find the vertex. Find the vertex, axis of symmetry, x-intercept, if any. So it is possible to not have any x-intercept. So if there are any, find x-intercepts, y-intercept, and grab the function. So let's find the vertex first. The vertex. Vertex, we need to first find negative b over 2a, and we plug the value into the function to find the y value of the vertex. Oops, like this. Write a little better. F of negative b over 2a. So this is the vertex. So here, this is b, this is a. So the x value of the vertex is negative 5 over 2a, which is negative 5 over 6. So this is the x value. So for y value, I need to plug this to right here. 3 negative 5 over 6 squared plus 5 times negative 5 over 6 minus 2. So I get 3 times 25 over 36 plus negative 25 over 6 minus 2. I get 75 over 36. So let's try to make each of these to denominator of 36, so we can have a common denominator to combine these to all one fraction. So I can multiply here 6 over 6. Then I get minus, well, minus plus becomes minus 36 in the denominator. And 25 times 6, well, 25 times 4 is 100, and we have 2 more 25 left, so it'll be 150. 150 minus 72 over 36, which is same as 2 right here. So then I get, so I can just subtract, or I can do 75 minus 150 and minus 72. Okay, so then I get negative 147 over 36. Okay, so this right here, so we have, actually we can simplify this furthermore. This would be negative 49. We can divide each by top and bottom by 3. So we get negative 49 over 12. So the vertex is negative 5 over 6, comma negative 49 over 12. So if you were to graph this, let's just plot this. So here's negative 1. So negative 5 over 6 is a little bigger than negative 1. Right? So somewhere here, let's say. And negative 49 over 8, or negative 49 over 12. Well, if it were to be negative 48, it would be exactly negative 4, right? So it's smaller than that. So it should be somewhere here, let's say. Negative 4 here is a little below negative 4. So it's smaller. So right here is a vertex. Okay. And axis symmetry is just this part. This x equals negative 5 over 6 is axis symmetry for the quadratics. That means along this line, the graph will be symmetry. Okay. So then let's find the x-intercepts. X-intercept, we can factor this. In order to find x-intercept, we have to set this equation equals 0. So we have to set 3x squared plus 5x minus 2 equals 0. We can either use quadratic formula, or if we can factor it, we want to factor it because that's a little simpler. So in this case, we can factor this to x and 3x, and plus 2 and minus 1. So this tells us that when x is negative 2, or when x is 1 over 3, oh, sorry, this is 0 here. This entire function is 0. Y value is 0. So when x is negative 2, or when x is 1/3, y value is 0. Therefore, 1/3 is, let's say, somewhere here. And negative 2 is right here. These two are x-intercepts. So this graph will intersect at these 2 points of the x-axis. For y-intercept, we just plug 0 for x. So 3 to 0 squared plus 5 times 0 minus 2. This is 0, this is 0, so we have negative 2. So y-intercept is -2. When x is 0, and it crosses -2 of y-axis. So now we're ready to graph the function. So we graph this. Again, we have to remember this is a parabola, and because it's a positive coefficient, it has shape of going up together, like this. And it will match this. Vertex is the minimum value for this. So it goes up and goes up, something like this. Again, this is symmetry, so left and right are symmetry here along this line. So this is the graph of this quadratic function. For the given polynomial, list its real zero and its multiplicity. Tell whether the graph touches or crosses the x-axis at each zero. Then graph the function. So first, let's find each zero. So this is already factored for you. So it's negative x equals -1. When it's -1 here, we get 0, right? So x equals -1, x equals 1, x equals 5 gives us zeros. Again, 0 is the same thing as the x-intercepts. Then we can find the multiplicity. So we can make a table, zeros, multiplicity, and cross or touch. So we have -1, 1, and 5. And -1 multiplicity is 1. Right? 1 is implied here. Same for here, same for here. So all these multiplicity is 1, which is odd. When multiplicity is odd, the graph crosses at that point. So at -1 it crosses, at 1 it crosses, at 5 it crosses. So now that we know that, we have to find more information as we are going to graph this function. So first, we also have to know the degree of this function before we graph it. The degree of this function, we have x, x, and x, right? So degree of functions, if you were to multiply this out, the highest degree we'll get is x to the third. So degree is actually 3 for this function, which is odd. When degree is odd, the polynomial will either end this way or this way, right? The end behavior. But in this case, it will be this way. Oh, let me delete. This way, because the coefficient is positive. So this is the end behavior of this polynomial. And of course, we have to fill in the gap here. So when we graph this, let me start here. We know that end behavior will be something like this and something like this. Okay. And we already know the x-intercepts. Let me mark it here. -1, 1, and let's say 5 is here. So maybe I should actually have this further away. Yeah, so end behavior is somewhere here and somewhere here. Okay. And one other thing we can find here is we can also find y-intercept. We can find the y-intercept by plugging 0 to the function. So when I plug 0 to here, here, and here, I get 1 times -1 times -5, which gives me +5. So when 0, 5, the function will cross here. So let's sketch this. Let me actually start this somewhere here for a better angle. Again, we're sketching it. Only thing really we're paying attention here is the x-intercept is crossing here and crossing the y-intercept and this shape. So it starts here, it crosses at -1, crosses here, and it touches y-intercept like this. And here it could go a little more up, but then it goes down and it crosses 1. And again, we don't know how low it goes here. So it could go all the way here, or it could go even more here. Okay, but we're just sketching based on what we know. So then it curve back, eventually it'll curve back at some point, and this would be a sketch of this graph or graph of this function. And again, just note that we have a limit information. The function could definitely look something like this as well. It could definitely look something like this. And it could go down even more. And it could just go like this. So there's many possibilities. But only thing we're paying attention right now is multiplicity, y-intercept, x-intercept, and the end behavior. So know that it could be your answer. The problem, if you try this on your own, what you graph might look a little different from mine. But as long as you have the same multiplicity of x-intercepts and same end behavior and y-intercept, you should be fine. Divide this function by x plus 1. So when we divide it, and if we remainder is 0, that means we can factor out x plus 1 from this right here, right? So we're going to do synthetic division. And dividing by x plus 1 is same thing as synthetic divide by negative 1. So we're going to do synthetic division, negative 1, like this. And 5, 3, and negative 2. So 5 comes down, 5, and we multiply negative 1. Multiply this negative 1 to 5, and we get negative 5. We write it right here. So let me show that again. What we're doing is we do negative 1 times 5, multiply this together, and write it right here. That's what's happening. And then we're going to add these two together and write it right here, which is negative 2. And then same thing, I'm going to multiply negative 1 to negative 2 and write it right here. Okay, so negative 1 times negative 2 gives me positive 2. And then I'm going to add this, and I get 0 here. And this is actually the remainder, right? Remainder 0 means I'm able to factor out x plus 1 from here. So let me write down what we did. When we divide 5x squared plus 3x minus 2 by x plus 1, I got as a quotient right here. This is x term, this is x0 term, which is essentially a coefficient. X to the 0 is 1, right? So I have 5x minus 2. I got 5x minus 2 because remainder is 0. If remainder is not 0, we have to add something here, right? To add the remainder divided by x plus 1, right? The remainder is 0. And it says write your answer in factor form. So that means this thing right here, the function we start with, 5x squared plus 3x minus 2, equals 5x minus 2 times x plus 1. I can factor by x plus 1. So I can either think as multiply x plus 1 both sides to bring it right here. But this also means I was able to factor x plus 1 out from this function. So now we have a factor form. For function x to the fourth minus 2x third minus 7x squared plus 8x plus 12, list all the possible zeros, use division, in this case we're going to synthetic division, to find all the zeros of polynomial, list each zero in multiplicity, and graph the function. So here I'm going to have to use several, more than one screen, more than this slide. So let's start with A. List all the possible zeros. For that, we look at coefficient here, 1 and 12. So we write 12 first and 1. So then we list all the factors of 12, which is plus minus 1, plus minus 2, plus minus 3, plus minus 4, plus minus 6, plus minus 12. And factors of 1, which is plus minus 1. So then what we do is we divide top number by bottom. So 1 over 1, 2 over 1, 3 over 1, 4 over 1, 6 over 1, 12 over 1. So in this case, actually, we only have one set of numbers, right? Only plus minus 1. So if I divide each of these by plus minus 1, I get the same original number that I start dividing by. So this actually just gives me plus minus 1, plus minus 1, plus minus 2, plus minus 3. So just write these again. So these are the possible rational zeros, possible x-intercept. These are the candidates we can use to synthetic divide. And let me remind you, if you have another number here, Let's say a factor was 3, hypothetically, or sorry, 2. Then I have plus minus 2 here, right? Then we also have to list like 3 over 2, 4 over 2, 6 over 2 to all these numbers. But here, because only coefficient was 1, we only have to worry about plus minus 1. So these are all the possible rational zeros. So starting from here, we can start to synthetic divide by to find the zeros. Okay. Again, before these numbers, we have no idea what the possible zero will be. So this actually narrowed down what number we can potentially factor with. Okay. So there's few ways to approach this. So now we're going to B. We can use rational zero theorem where if I plug a number, let's say if I plug number A, that gives me 0, that means I can synthetic divide by A and the remainder will be 0. So for example, if I plug 3 here, 3 here, 3 here, 3 here, 3 here, and if it simplifies to 0, then I know that I should divide by synthetic. I should synthetic divide by 3. So that's more efficient than just trying synthetic division until we get remainder, right? So let me do an example. So I'm gonna plug 1 in to this function. So I have 1 to the 4th, 2, 1 to the 3rd, 7, 1 square, plus 8 times 1, plus 12. So let's simplify this. I get 1 minus 2 minus 7 plus 8 plus 12. So this gives me negative 9 plus 8 plus 12 gives me 11. So I did not get 0. That means I should not synthetic divide by 1. It will give me a remainder. Okay. So now let's try negative 1. F of negative 1. So I'm going to do negative 1 fourth square. Oops. Minus 2 negative 1 third. Minus 7 negative 1 square. Plus 8 times negative 1 plus 12. So I get negative 1 to the 4th power positive 1. This is negative 1. Negative 2 is positive 2. Positive 1 negative 7 minus 8 plus 12. So here I get 3 minus 7 is negative 4. Negative 4 minus 8 is negative 12. Negative 12 plus 12 is 0. So that means that I can synthetic divide by negative 1 because it gives me 0. So negative 1 is an x-intercept. Okay, so that means I can factor out by x plus 1. Right, it's opposite sign. So again, I'll need more room here. So I'm going to go here. And again, we're trying to factor by x plus 1 now, because that means this x-intercept is negative 1, right? So I'm going to synthetic divide by negative 1. So let me write down those coefficients. 1, negative 2, negative 7. 8 and 12. Let me just double check. I guess I also written here, but yeah. So now we're going to synthetic divide by this. So 1 comes down. Negative 1 times 1 gives me negative 1. Add. Negative 1 times negative 3 gives me positive 3. Negative 4. Negative 1 times negative 4 gives me positive 4. Negative 12 and 0. I mean, we already knew that remainder should be 0. Now, the reason we're doing this is because now we have coefficient for x to the 4th, 3rd, 2nd. Oops, actually, sorry. We started x to the 4th. So this was coefficient for x to the 4th, 3rd, 2nd, x, and x to the 0, which is just a coefficient, just a constant. When we divide, we have actually the 1 less, right? Because we factored out x plus 1. So now what this tells us is that when I divide this thing right here, x to the fourth minus 2x third, the original equation, when I divide this by x plus 1, I have left with, the quotient is this right here, x to the third minus 3x squared minus 4x plus 12. So again, we can also rewrite this, right? This means that when I factor these out with x plus 1, I can multiply x plus 1 here, right? Let me write that better. So I can do this times x plus 1. And since I divide by, I don't have to write this here. Let me erase this. Like this. Right? But still, we still need to do synthetic division, do a little more for this portion now. Or from here, we still need to continue the synthetic division. So now the question is, so let me erase this. So we can continue to synthetic divide using 1, -3, -4, 12. Essentially, we're trying to factor this out. That's what we're doing here, right? So what number do we start with? Same idea. Start from this rational zeros. But the important thing is that same number can be used twice. So it is possible that -1 will work again. Okay? So from here, I have to pick another number or same number, -1. Okay? But I can tell you that -1 doesn't work because I've tried. So we can do this same thing again as we've been doing here. Plug a number. If I plug, for example, f of 2, I can tell you that if you plug f of 2, I get actually 0. Okay, so if you try yourself, if I plug 2 here and simplify, I get 0. So that means 2 works. So I can synthetic divide by 2. Okay, so I can synthetic divide by 2. And let's check. 1, 2 times 1 gives me 2. -1, -2, -6, -12, remainder 0. Good. So that means we're able to synthetic divide by, in this case, x, well, we have to factor by x minus 2. And we have, this is now x squared term, and x is 0 term. So far what we did is we're able to factor out, let me write it, x squared minus x minus 6, and we're to factor with x minus 2 and x plus 1. So this right here, we just factor to these two, like this. Now once we're here, we can still do synthetic division, but we don't need to. Because we have a quadratic, here we can actually just factor using what we, either quadratic formula or just factor using 2 parentheses like this. So this is actually x minus 3x plus 2. X minus 2, x plus 1. So this right here equals this thing. We were able to factor. And the reason we do this is so that we can find the x-intercepts. X-intercepts are 3, -2, 2, and -1. Okay. So let me go to the next page where I have a graph ready. So I'll just rewrote what we found earlier. Then we can find that we have 3, -2, 2, and -1. And each of these multiplicity is 1. So all these just crosses. Right? Cross, 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 cross. So let me mark this here. 1, 2, 3. 2, 3, 4. So we have 3, 2, -1, and -2. It passes this 4. It crosses 4 x-intercepts. And we need to find more information. We can also find the y-intercept. Y-intercept, we can actually plug 0 here. Then we'll get 12. Right? So y-intercept is 12. So we can just mark it with 12 here. because if I plug 0, 0, 0, 0 here, only thing I've left is 12. Another thing is we have to know the end behavior. Since the coefficient is even, right, the degree is 4. So n is positive number here. The function, the end behavior will be like this, go up together. Okay, so now we're ready to graph. We know the end behavior will be like this, like this. So it goes down here, and -2 it crosses. It also crosses at here, and it also touches y-intercept, crosses, and once it crosses, we actually don't know at this moment how low it goes. Crosses, crosses. Oops. Let me do it again. So here, it actually should cross here. And goes low at some point. At some point, it turns away and crosses here. So this is a sketch of this graph. Okay, so let me highlight it. And maybe it looks like a straight line, but it actually should be a curve. So if I zoom in, and if I actually draw more precisely, it should be, all this should be curve. And not straight line. So maybe the green one would be better. Like this. So I think this might be a little better, because polynomials are always curves. I mean, it may look like a straight line if you look at it from far away, or if you zoom in, but yeah, it's always curved.